Hi Year 13s. In this video we're going to look at even and odd functions. And so I've got two definitions here, each for an even and odd function. So a function is even if when you put a negative value of x in, you end up getting the same value for your function of positive x. And an odd is simply the opposite of that. If you put in a negative value of x, you'll get a negative value of your function. So we're going to look at 4 examples here and try and determine if they're even or odd by their graph. And so the first one I've got here is x squared, so I'll do that one first. So we'll put the points in for that. So I'll start at 0, 0. 1 squared is 1, 2 squared is 4, negative 1 squared is 1, negative 2 squared is 4, and we'll sketch that in carefully. Okay, so that's y equals x squared. And so basically what we're looking for here is, do negative values of x yield the same values of y? And we can see here that indeed if you put negative 1 in, you still get positive 1. So because we've got those matching of values on both sides of the axis, this is what we'd call an even function. So that x squared, y equals x squared, is an even function. Okay, so let's look at the next graph, which is y equals x cubed. And so 1 cubed is still 1, and 2 cubed is 8, well that's way off the scale. Negative 1 cubed is negative 1, because negative 1 times negative 1 times negative 1 is negative 1, and negative 2 cubed is negative 8. So we're going to have a graph that looks something like this. It goes through like there and then curves back down. So in this case, because we've got a positive value for positive values of x and a negative value for negative values of x, that graph y equals x cubed is going to be an odd function. Okay, so it's really just a definition trying to explain different functions. So let's look at the graphs of sine and cos. And so with the sine graph, you should be able to get familiar enough with it that you can just sketch it straight up. So the sine graph starts at 0, 0, peaks up at pi over 2, back down to 0 at pi, and then down to negative 1, and then back up again, and follows that cycle. So it looks something like this. Try as hard as possible to sketch that in. Okay, and if we can continue that pattern into the negative, so we'll draw in the points first, and then it will continue into the negative like this. Like so. And so when we're determining whether or not we think this graph, so it's y equals sine x. So, I did number 4 first, but that's right. So when we're considering whether this is odd or even, we're looking at positive values of x, so say that value there, that's pi over 2, and comparing it to negative values of the same magnitude, so negative pi over 2, and here we can see that although a positive result yields a positive y result, a negative x gives us a negative result. And so that means that this would be, if we refer back to our definition, an odd function. So it is an odd function. Okay, so let's have a look at the graph of cos x. And so that starts at 1 and goes through there, gets to the bottom there, and then up. So it's sort of out of phase with sine by 90 degrees. And there we go. And if we follow that negative, it'll look like this. Here we go. And that would be y equals cos x. So looking at the values for this one, if we've got a positive value for 2 pi, if we look at negative 2 pi, we've also got a positive value. Likewise, for a positive value of pi, we have a negative value, and for a negative value of pi, we also have negative. And so cos would be an example of an even function. So cos y equals cos x is an even function. So those are just two definitions to be familiar with. You'll probably notice little things like even functions are symmetrical about the x-axis, sorry, the y-axis, while odd functions are symmetrical about the diagonal line y equals negative x. And things like that certainly help you identify them as well. But that's all I want to talk about. There's no actual work for those examples. I just wanted you to be aware of what they mean.